So now we'll see the extension of Pascal's law. So some more result we want to see, because when we studied the Pascal law, we come across this relationship. And from this relationship, we were getting that F1 is F2, meaning we were getting that if I apply the force F2, I get the F1 force. So is it similar to the energy also? Because see, if this is applicable for force, the same should have been applicable for the energy also. That's the thought process actually. We just want to check that thing. Because if I can somehow increase the amount of work I'll be getting out of my force, I'll be very happy to do that. So let's check for it. So what I do, this time I apply the same force F1 and F2, and these are same, but they're slightly different. They're slightly different because of which these pistons are getting displaced. But during displacement of the piston, their velocity is approximately 0. So this fluid is not having any kinetic energy. There is no transfer of kinetic energy which is happening. So all the work done by the forces is happening onto the piston. So first of all, let's think about the displacement. Here I have assumed that this piston has moved up by x2 and this piston has moved down by force x1, by displacement x1. So this has moved down by x1 and this has moved up by x2. So obviously we know this fluid is incompressible, because this law is only applicable there. So if this fluid is incompressible, its volume cannot change. So whatever decrease in volume has happened here, the same amount of increase in volume has to happen on the other side, meaning this has come down, this has gone up. So this has pushed the volume down and this has pushed the volume up. The volume or liquid has pushed this piston up. So this volume and this volume has to be same. So if we make the relationship between the volume, this x1 multiplied with capital A, that's the volume here, it's a cylindrical, and this should be equals to x2 multiplied with small a. Or we can say x1 upon x2 is equals to small a upon capital A, which is less than 1. Because the same relationship, capital A is more than, this is just the extension of the previous problem. So see, if you see this and here, this relationship. So one more relationship we have got actually, this F1 upon F2 was capital A upon small a, and which was more than 1. So you see, from there we were getting F1 is more than F2, and from here we are getting x1 is less than x2. So though my force is increased, corresponding to that, my displacement has decreased. So here I'll be displacing by x2. So I apply a smaller force, but the displacement is more. I get a more force, but the displacement is less. So that's the kind of thing happening here. So I want to check the power delivered, or the energy basically. If I want to check the energy, meaning amount of work done by this force and the amount of work done by this force, the amount of work done here, if I make that work done as W1, that amount of work done W1 will be equals to F1 into X1, isn't it? And the amount of work done there, it will be equals to, W2 will be equals to F2 into X2. So now we have a method to convert the F1 into F2 and F2 into F1, and similarly displacement also. I want to do that. So I want to relate this W1 and W2, how they are related. So W1 depends upon F1 and X1, and W2 depends upon F2 and X2. But the thing is, these two values are connected and these two values are connected. So what I'll do, I'll start operating with W2. So since this W2 is F2 into X2, so what I'll do, I'll go here. And from this relationship, we can see F2 is equals to, I'll take this small a on this side. So this F2, I can write it as small a multiplied, small a divided by capital A multiplied with F1. Now this is the F2. From here, we have replaced the value. Now this X2 is also there. So you see X2, or here X2. So in place of this X2, I can write the value in terms of X1. So it will become X1 into capital A divided by small a. So this and this cancel out, which is the same as the W1. So this W2 becomes is equals to W1. So there is no benefit basically. We were thinking we will be able to get more work, but the work is same. You have to do equal amount of work done here as well as here. The only thing is, You cannot increase the work done, but you can change the amount of force you'll be getting onto the other side. So if you want displacement, if you want more displacement, you'll be putting, let's say we are having an object, and if I want to move that object with a faster speed, I'll be putting that here, because with smaller displacement here, the displacement will be more. With a smaller speed here, the velocity here will be getting the more. But if there is a heavier object and we just want to lift that object, if that's our objective, we'll put that heavier object here. So with the application of a smaller force with more displacement, smaller force, greater displacement, we'll be able to get greater force, smaller displacement. So the efforts will remain same. The only thing which will change will be the amount of force you have to apply. And let's think this from the point of view of bicycle, because everybody must have driven bicycle at some point of time. They must have ridden that bicycle. So we used to have a bicycle which used to have the gears, so if you remember. So that gears. So when there used to be flat surface, we generally used to go for the lower gears, meaning we used to, higher gears, 4 or 5. Because when there is a flat surface, our main objective there becomes the speed. But when we go for incline, and in case of incline, with the heavier gears, efforts required will be more. So there will be a limit. The main constraint will become the efforts. We don't want to put that much efforts. So what we do, we go for lighter gears, meaning we go for bigger gears there. So the thing is, we have to paddle more, but our thighs, our legs, they are rested there. So the thing is, heavier gears, lower gears, the same thing here. So if I want to just lift the object, and if my constraint is the force, so I'll apply the force here, I lift the object from here. If the force is not the constraint, and we want more displacement, I'll apply the force here, and I lift the object from this side. So this is the thing. So this is some sort of a arrangement by which we can change the force, but we cannot change the work done. That's the law. You cannot change. You cannot increase the amount of work done you can get through some medium. Whatever amount of work done you apply, the same amount of work done or less amount of that work done you can get. So that's it. We'll do some more problems.